Hello everyone, I'm Vishnu Supratik. I'm studying in SVC Bengaluru in the Department of Basic Science, first semester. So in this video, we'll be talking about the concept centroid and numerical on centroid. So basically, this is going to be an asymmetrical figure and we'll be finding the centroid of this given figure. So let's hop on to the question. So before moving on to the question, what is a centroid? A centroid is a center point of an object or any given figure. For example, if we take a triangle, this is the centroid of a triangle. Talking about square, this is the centroid of the square, and this is the centroid of a circle. So next we move on to the question. Find the centroid of the given asymmetrical figure. So we are given an asymmetrical figure. If we divide it into known minimum components, we'll have four components. That is rectangle, semicircle, triangle, and another rectangle. In the next slide, we'll see what are the components and its measurements. First one is rectangle. So this rectangle has breadth of 40 millimeter and 5 mm in depth. And talking about the centroid of this rectangle, we need to divide depth by 2 for getting the distance between centroid from x-axis, and the distance from centroid to y-axis we need to divide breadth by 2. As we can see here, b by 2 is nothing but 40 by 2, that is 20, and here d by 2 is 5 by 2. Upon calculation we'll get 2.5. Moving on to the next figure, another rectangle. So this rectangle is 5 millimeter above the x-axis, and the dimensions of the rectangle is 12 mm in breadth and 20 mm in depth. As to find the centroid of the rectangle, we need to divide depth by 2, that is 20, and we need to add this 5 to get the distance between centroid and the x-axis. So nothing but this d by 2 distance and this 5 millimeter. And the distance from y-axis to the centroid is b by 2, that is 12 by 2. So 12 by 2 we get 6, and d by 2 we get 10, including this 5 millimeter we get 15 mm. So the centroid uh, is 15 mm above the x-axis and 6 mm in front of the y-axis. Moving on to the next figure, semicircle. So this semicircle, like the previous rectangle, is also above 5 millimeter above the x-axis. So the dimensions of the semicircle is, the diameter of semicircle is 20 mm, so the radius is 10 mm, and it is 12 mm in front of y-axis. So as given by the formula, to find out the centroidal distance from y-axis, we need to calculate this part, 4r by 3 pi plus 12 millimeter. And from x-axis, the distance to the centroid is d by 2, which is nothing but r. We'll next move on to the last figure, which is triangle. So triangle over here is 25 millimeter above the x-axis, and the dimensions of the triangle is 12 mm in breadth and 5 mm in height. So this is a right angled triangle. So as to find out the centroid, we need to divide height by 3 and add this 25 mm as to find out the centroid from x-axis. So h by 3 will give around 1.6 as the answer, plus 25 will be 26.6, which we'll see in the next slide in the calculation table. So I'm giving a rough idea to you to understand. And the next one, the centroidal distance from y-axis is b by 3, which is 12 by 3, which we get as. So yeah, next we'll move on to the calculation table. We'll calculate the values one by one. First, we'll take the rectangle. The component is rectangle. As we all know, area of rectangle is b into d, which is nothing but 40 into 5. So 40 into 5 we get as 200. Centroid distance from x-axis is d by 2. From x-axis it's d by 2. So d is 5. 5 by 2 is 2.5. Moment of area about x-axis is the multiplication of area and centroid distance from x-axis. So it's 200 into 2.5, which gives us 500. And the centroidal distance from y-axis is b by 2. B is 40 and 40 by 2 we get it as 20. And moment of area about y-axis is again centroidal distance from y-axis multiplied by area. So it's 200 into 20, which we get it as 4000. So yeah, next we'll move on to the next rectangle. This rectangle, number 2. The dimensions of this rectangle is 12 mm in breadth and 20 mm in depth. So B into D is 12 into 20, which is 240. And the central distance from x-axis is D by 2 plus 5. As said earlier, we need to add this D by 2 as well as 5 mm to calculate the distance between x-axis and the centroid. So it's d by 2 plus 5, which is nothing but 20 by 2 plus 5, which we get it as 15. Next, moment of area about x-axis is the multiplication of centroidal distance from x-axis and area. 240 into 15, we get it as 3600. Next, central distance from y-axis is b by 2, which is 12 by 2. We get it as 6. And the moment of area is 6 into 240. We get it as 1440. Talking about semicircle, the area of semicircle is pi r square by 2, which is pi into 10. 10 is the radius of the semicircle. So 10 the whole square into pi by 2, we get it as 157.07. And the centroidal distance from x-axis is r plus 5, as seen in the previous diagram. R plus 5 is the distance between x-axis and the centroid. So it will be 15, and the moment of area is 157.07 into 15, which we get it as 2356.05. Next, the centroidal distance from y-axis is 4r by 3 pi plus 12. This is 4r by 3 pi. This distance is 4r by 3 pi plus this distance, which is 12. So yeah, 4r by 3 pi plus 12, we get it as 16.24. Next, moment of area about y-axis is 16.24 into 157.07. We get it as 2550.81. Next, we calculate the area of triangle, which we know as half into base into height. So half into base is 12 and height is 5. So we get the area is 30, and the centroidal distance from x-axis is h by 3 plus 25. So this distance is h by 3, and since we are calculating from x-axis, this is the distance we require to add with h by 3. So it's h by 3 plus 25. H by 3 plus 25 upon calculation we get it as 26.66. And the moment of area about x-axis is 26.66 multiplied by 30. So it's 799.8. The centroidal distance from y-axis is b by 3. So yeah, this distance is b by 3. B by 3 is 12 by 3, which we get it as 4. And lastly, moment of area about y-axis is nothing but calculation of central distance from y-axis and area. So it's 30 into 4, which we get it as 120. At the end, we'll have to calculate the sum of area and sum of ay and sum of ax. Here, the sum of a upon calculation, we get it as 627.07 mm square. And sum of ay, we get it as 7255.85 mm cube. And sum of ax, we get it as 8110.81 mm cube. So this is the calculation part of the components. Now we move on to the last part of the question, which is finding out the x bar and y bar, which is nothing but the centroidal distance from x-axis and y-axis of the given asymmetrical figure. So yeah, x bar's formula is sum of ax by a, sum of ax by sum of a, which is nothing but 8110.81 divided by 627.07. Upon calculation, we get x bar as 12.93 mm and y bar is sum of ay by sum of a, which is 7255.85 divided by 627.07. Upon calculation, we get the answer as 11.57 mm. So this answer tells us the centroidal distance is 12.93 mm from x-axis and 11.57 mm from y-axis. So yeah, in this whole asymmetrical figure, the x bar is about 12.53 and the y bar is 11.97. So this is it for the video. Thank you for watching. Bye bye.